Hello, thank you for coming back. And today, if you recall, last time we discussed how to solve linear equations. Today, we are extending that concept to solving different kinds of, not equations, but what we call as inequalities in one variable. Give you a small typical example. Suppose you have an inequality 3x minus 4 greater than or equal to 5. I hope you can recall this symbol means greater than or equal to. So just like we did in equations, one of our primary purpose in solving inequalities is to isolate the variable on one side and the constant terms on the other side. How do we do that? Very simple. Just like as we do in equations, we add 4 on both sides so that 4 is transferred to the other side. Remember, in equations or inequalities, whatever we do on one side, we have got to do the same thing on the other side. So now add them up. This 4 cancels out. So you have 3x greater than or equal to, you add them, becomes 9. So variables are separated on left and constants on right. And next, again, just like equations, you now divide with the coefficient of x to have exclusively the value of x. So you divide by 3, and 3 gets cancelled out. So you have x greater than or equal to 3. That's the final solution. But now the question is, how many values x has that can be called a solution of this inequality? Is it 3? Or is it more than 3? Or both? This symbol indicates what it should be. It's greater than, any value greater than 3 is a solution, including x equal to 3. So, doesn't matter what type of inequality you have. If you know how to solve linear equations, you should also be able to know how to find linear inequalities. Process is exactly the same. The only difference is that equations have single solution, unique solution. Inequalities have infinite number of solutions. In this case, all numbers greater than 3 are solutions.